software professionally for about more than 2 decades now. Talking about my hobbies, they keep changing. The last hobby I had was like watching movies. Yeah. Before I start, I wanted a photo. Thank you. Folks, this is going to be an interactive conversation. Stop me whenever you have a question. I'll keep it as a dialogue wherever possible. The title of the talk is, If It Ain't Tight, It Ain't Done. About myself, I'm an engineer, speaker, teacher, writer. I strongly believe in the theory without practice is empty and practice without theory is blind. I strongly believe and I've practiced this for 2+ decades of working as an engineer. I write on Medium, and that's my LinkedIn profile. Feel free to connect with me or follow me. Disclaimer, I'm speaking on my personal capacity. My views don't represent that of my employers. I use pictures in this slide deck. Some of them are come from Google searches. This is my 4th consecutive talk at this forum, but I'll repeat this. What is the fastest way of going from the bottom to the top? What is the fastest way of going from the bottom to the top? You have these options, and it's a functional escalator.
It depends. It depends. You walk on escalator, then you can go fast. If you run the stairs,
yes,
then you can go fast.
Yes. So the metaphor here is stairs is working hard, while the escalator is working smart. The fastest way is a combination of working hard and working smart. I believe as an industry we tend to work too hard and not smart enough. And over the last few years I'm trying to evangelize smart ways of working. Next slide. Folks, how many software principles are you familiar with? 5. Pick a number. 10, 15, can go on.
They are numerous.
Huh? They are numerous. But for most of us, it will be around, I guess, 5 to 10. Now, the premise of this talk is a lot of the principles are actually derivatives of principle which I am not talking about. Yeah. I am going to talk about a principle which is a generalization of most of the principles of choices everywhere. In the introduction, I heard people talk about foodies. Any foodies here? Would you like your food to be tasty or healthy?
Healthy.
Both. Yeah. So, going back to digital electronics, which function would you want to apply? And. Okay. What is gap theorem? In the presence of partitions, So I call this AND choices and XOR choices. Too often we assume things are mutually exclusive while they are not. Food can be tasty as well as healthy. So the principle I'm going to talk about is a variant of this AND. Yeah. So cap is an instance of the XOR choice or XOR function, while the food choice is an example of the AND function. Now let's assume there's a game show, and the participants have to give the right answer. If they press the buzzer fast but don't give the right answer, they don't get the point. So they get the point if and only if they have the right answer and they are the fastest to press the buzzer. So this is a pictorial representation of this. If they are fast but wrong, they don't win. If they are correct but slow, they don't win. The magic spot is here where they are right and they have the fastest response time. This is the manifestation of our example principle I'm going to talk about. Now, there's a variant of this principle where the game rules are, if they press the buzzer and they're wrong, they lose points. But if they press the buzzer, the points they get is, say, 100 minus how many seconds they take to respond. The slower they are, the fewer the points they get. So these are the two manifestations of the principle I'm going to talk about. Okay. I guess most of you are, I need a volunteer. Simple question, don't worry. What did you have for breakfast 1st of January 2008? Okay. Did you drive to Devon today?
No.
Okay. How did you?
I came by bus.
How many cars did you see on the road?
100,000.
No, I need the exact number. Who's good in maths? What is 212 into 877?
Say some number.
Okay. I'm going to say a phone number. I want you guys to, one of you to, I'll pick a volunteer. I'll pick the first volunteer. Don't write the number down. I want you to memorize and tell me the number. 9008 7 2 3 8 7 5. Okay. Yeah. What's the number?
87.
Okay. Okay. How many of you got the number right?
90087.
Okay.
90087230005.
Wrong.
No, 72.
Okay, guys. The point is, human memory is fallible. The amount of information we can recollect is limited. The amount of computations we can do in our brain is limited. But we build rockets, we build tanks, we build computers, supercomputers. There must be something good about us that is allowing us to do these things. So, I'll speak about some of these. So, humans are slow. we have limited memory. We get easily fatigued. We are prone to errors. We are driven by ideas, not by details. And compared to machines, we are costly. So, lot of software development principles are based upon these limitations of humans. And I'll talk about each of them. The first process we have is sort of abstraction. Now, what is seen in front of you is a combination of, I don't know, how many trillions of atoms. Your brain has condensed everything into maybe a two-dimensional or three-dimensional view. So, what were you doing in 2008, sir?
Was working at a manufacturing company.
What were you doing on the 1st of January 2008? So, this is a good example where there's a lot of information. We continuously throw away information which we think is not important and retain only as a information. This is the process of abstraction. Now, abstraction again, if it is too abstract, it is meaningless. If you remember everything, it is also not useful. So, the right level is somewhere in between. So, the essence of abstraction is preserving information that is relevant in a given context and forgetting information that is irrelevant in that context. None of you spoke about your personal life, your romantic life. Oh wait. That is the irrelevant information in this context. So, human thinking is based upon this filtering of irrelevant and seeking to what is relevant. So, capture as little as required is a restatement of the abstraction process. What is right is very contextual. In one context, things like the medical history and genetic history are relevant to the same person. In different contexts, the commission rate, cars sold and name are chosen. So this contextual filtering is what is another manifestation of this principle. Now, on the right hand, on the left, there is method implementation, and on the right is an equivalent method broken into sub-methods. Which of this is better and why? Yes, sir.
The left one, because it essentially tells you what you are doing and why you are doing it, and you can actually try to, in case you want to do things differently, you can do it, otherwise that will be a shit code.
Yes, this is similar to that 213 into 875 multiplication problem I gave. This provides the summary, and we can dig into the details where required. So, if you look at readability of methods, beyond a certain size of a method, the readability comes down. So, software development, at least as of now, is still a human-driven process. So, it is important to tailor our practices to the human limitations and strengths. So, this is the next manifestation of the principle. Don't wrap more than it can be easily understood. understood. Yeah, how many of you watched Game of Thrones? Imagine Daenerys introducing herself each time like this. Versus, there's a label called Daenerys and which encapsulates all of this. So if you go back, if it ain't time, it ain't done. Talking about each time most of the time, we refer to this instead of this. It is Daenerys, but not D. It is Daenerys, not Daenerys of House Targaryen, the first of her name, the blah 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 blah. So we do this sweet spot between capturing too much and too little. Earlier I spoke about how we need to get the right level of abstraction. Here I am talking about the right level of encapsulation. So encapsulation is something we use at a class level, method level, microservice level, package level. This is something we have to do. Yeah. Now go back to this. In this representation, that calculate some other stuff can be used if and only if it is used in the context of some method. But moment you pull it out into these three methods, these can be used independently. By the act of breaking down something into smaller components, smaller modules, you have more usability. In the world of medicine, they use a metric, maybe one is called efficacy, other is called effectiveness. One speaks about how powerful, how functional it is in a similar group or test group, while the other speaks about how it will perform in the real world. A medicine which is efficacious but not effective is not desirable, nor the other way around. We need the medicine to be both effective and efficacious. By making things modular, you are satisfying the use case in hand as well as keeping it open for future reuse. Okay. Why do we normalize data?
To avoid redundancy.
Remove redundancy to ensure there is no redundant information.
No, that is what we do. But why?
To keep it relevant actually.
It's relevant.
Relevant, to keep relevant. Data should be, as of before the normalization it's kind of raw format. So we need to bring it to a format where it can make the data should be meaningful when it comes
No.
to.
The extraneous data is removed and all data that is sort of together, meant to be together is together and
To make
anything
it
that
more
is-
granular.
Why?
Easy to organize.
Easily manageable.
Okay, folks, what are the anomalies which data normalization fixes?
To get consistency around the data.
Okay. The answer we're looking for is there are update anomalies, delete anomalies, insert anomalies. You prevent a set of these problems by normalizing data. So, in addition to reducing data redundancy, you are improving data integrity. By making things smaller, by fitting in. Now, what is wrong if data is not normalized? The developer at that time or the engineer or whoever has to remember the fact that if I delete this, I have to delete there. If I update here, I have to update this. Given how well we fared in recollecting what we do, remembering how many buses we saw, really think we can do it? So, the takeaway here is, by making things modular, you are improving the understandability, the maintainability, the reliability, performance, and effectiveness. Folks, I'll quickly go through this metric I found recently. Given a piece of code, they look at 4 different parameters. Number of unique operators, number of unique operands, total number of operators and operands. And they derive some other metrics: vocabulary, length, volume, difficulty, and effort. I've taken that metric on this piece of data. 1024 is 2 plus 2 plus 2 repeated 512 times. 1024 is 2 into 2 into multiplier repeated 10 times, and so on. All of this represent the same information. But if you apply the metrics I spoke about, you will see that difficulty to understand the addition method is more than that of the multiplication, which itself is less than more than the exponent method. A simple example to manifest.
Can you just go back again to the Halstead? The Halstead, what is he saying? Difficulty is a factor of complex.
I didn't define this.
Yeah, that's fine. I'm not saying. Right, thank you.
So there's one key takeaway I wanted to have from this slide. In these two, there is exactly one operator. Okay, maybe suppose I'm interpreting this. There was one operator in the multiplication and the addition example, while there were 2 operators, actually 3 operators here in the exponent. So the variant which had the richer vocabulary had the least difficulty. On the contrary, if somebody who did not know what exponents are, what brackets are, how do we combine things together, there is a learning curve. But the cost of learning is offset by the difficulty, length, volume, and effort in this example. So I'll give a software example: image compression. You can have lossless compression and lossy compression. I have taken 2 examples. One of them is called Rundle encoding, other is Huffman encoding. Folks, our universe is full of repetitions. There's significant difference, but there is significant repetition. If you find 10 people or 20 people, the probability that all of them are born on different dates comes down significantly. And if you take a sample of all the names over here, there might be at least one name repetition. At an atom level, at a molecule level, at a chemical level, there's repetition. So, repetition is there everywhere. In databases, in classes, objects, blah, blah, blah. So the takeaway here I want to say is, as we move towards fewer number of distinct operators and the number of distinct constructs will be significantly fewer than the number of occurrences. So the first of the construct here is basically conceptualization. Given integers 1, 2 and 3 or 1, 2 and possibility 4, we try to come up with the concept of an integer. The class is a distinct construct from the instances. Now, in addition to dealing with three objects, moment we have a concept of a class, we can reason in terms of the class and not in terms of the objects. So the vocabulary increases, but it will come back and repay in other contexts. So a richer vocabulary allowed you to come up with a less difficult representation of a problem compared to the one with a simpler and fewer vocabulary. The same with, given a bunch of classes, you will end up in scenarios where classes with themselves have commonalities, in which case you extract a supertype and so on. Folks, when was the last time you have heard of improvement to quicksort? The last time binary search was improved? How buggy do you think is the MapReduce code? Now compare this to the application code you write. How frequently does it get patched, updated, fixed, enhanced? Why? What's the difference between binary search and your piece of application code?
We do the improvement every day.
Now, why can't you write your code in a way? What's the difference between your application code and binary search?
We are using the binary search.
No. Why don't you rewrite binary search algorithm while you rewrite your classes?
The requirement is fixed. So here what happens is the requirements change.
Yes.
And here the requirements are constant. We know it's a specific modular task. This has to be this much of it. But here it's
Yes.
enhancing, changing.
So the language I want to say is the application code tends to be open while all of this are closed. But over time, if you pay attention to your application code, you'll come up with clear specifications for parts of your application code which become frozen or closed. So going back to the previous example so far, represent with as few as possible. Instead of saying Naveen does this, Ashok does this, Guru does this, we can talk about participants do this. Instead of saying again the same thing, speakers do something, participants do something. So, where possible, reason with classes, reason with supertypes, and represent with as few as possible. The operative word is possible. You cannot condense information beyond a certain point. I talk about it. And as software developers, close your methods and functions as much as possible. Okay. How many bits are required to represent a variable which can take 10 unique values?
Log into the base 2 plus 1.
Ceiling of that.
Huh?
Ceiling of that.
Yeah, ceiling. I mean,
Yeah.
that's what it is.
So anything less than that number, you will not be able to represent. Anything beyond that number is waste. So this is the log of the graphical representation of this. This
It's also what Shannon's information theory concept is essentially saying.
so Shannon is even more
Yeah, he's more
advanced,
advanced,
yes.
but I mean,
I didn't want to talk about it.
Yeah.
I just. So on the y-axis, this axis represents n. Sorry, this represents n, and this represents the number of bits required to encode that value. The same concept of condensing information is what we do when we use interface-driven design, component-driven design, and I'm using this to refer to my earlier talk on the same forum. I've spoken about axis variation in the platforms here. Okay, this is from the imperial system of measurements. Can somebody tell me fast how many ounces are there in a ton?
there are 2,000 pounds in a ton, and there are 16 ounces in a pound. 16 ounces.
No, I have the breakup here. Ounce to pound, pound to stone, stone to 125.
Yeah, so 16 into 2, 32,000.
Give me a number.
32,000.
Good. Folks, how many kilograms? How many grams are there in a kilogram? It is easier. The metric system or the imperial system? Why?
It depends who you ask.
No,
If you ask the Americans,
No, we're talking about
average
smart
American-
people. We're talking about smart people. It's not about Americans. Okay. Yes.
Base 10 system. It's easier to calculate.
No, it's not just that. The number of constructs is basically this 10 multiple, power 1, power 2, power 3. Here it is not uniform. So, I'm talking about how we can eliminate verbose representation. So things like base classes, generics, higher order, higher finite types are all applications of this principle. The more concise your code is, the richer your vocabulary can be. But beyond a certain point, you can reduce the vocabulary as well. Going back, if you think of this axis as your requirements and this axis as your design, the size of your code does not need to grow linearly with your requirements. It can be a lot more compact. But if you have 8 bits to know 8 different values, you can't go below 3. There is an optimum number which you cannot go below. So you have moves from here to here, here to here, here to here, and so on. This is a counterpart of refactoring called transformations, where how do you move code from here to here, here to here? How do you increase the scope of your code? How do you grow your code but still do it in a constrained manner? These are called transformations. A function, a method which was not taking anything will take a constant as a parameter, will take constant. From somewhere it can move to a variable. Instead of taking one, it can go, it can take an array of things and so on. So you can, there are prescribed ways of growing your code. So the key is is figuring out whether your code is in this phase or it has to go into this phase. How do you gradually increase the size of your code is a choice we as programmers need to do. This is from the philosophy of software design. The author speaks about three different, basically having deep interfaces. Ideally, we want powerful abstractions. Generics is a more powerful construct compared to types and interfaces. Higher order types are a higher abstraction than generics and so on. This is a pseudo-scientific representation. When you write software in a non-modular approach, the time to write software will increase. The size of software will increase. The number of closed modules will increase very slowly. But if you were to write software in a modular fashion, the number of closed modules is the one that is actually increased fast. The time to develop software will be a lot smaller, but it may increase in a step manner, and so is the size. So the time spent upfront in figuring out are we here or are we here is what will help us develop faster in a more reliable manner. So, multiplying two 3-digit numbers was hard for most of us. Hence, this is an example of dealing with information overload. The practice of iterative development is to address the same problem. Our brains are not equipped to deal with a lot of information. So we condense and say, what can we do in this state? So iterative development is a manifestation of this principle. Commit to as much as can be done with confidence. Not chewing more will be counterproductive. So folks, so far I have spoken about information, dealing with information. Do not bite more than what you can chew is the manifestation of abstraction, encapsulation, inheritance, information hiding, and so on. Now I'll talk about time investment. Why do we do continuous integration? What's wrong if we delay integration?
You find bugs early.
So,
Time to deliver. Little bit.
Avoid conflicts.
no, you will anyway find problems. So what is the benefit of finding them early?
You can fix them faster before you are.
We focus
Yes.
on one
Basically get
particular
early feedbacks.
if we continuously.
No. Why does early make sense?
So that you don't have to have other things become bug compatible.
Connected issues will be more
You will remember the cost.
Yes. The cost of detecting a problem early is beneficial compared to capturing it later. So, continuous integration, doing code reviews and design reviews, conducting stand-ups, giving demos of your code, doing retrospectives of what has done. I'll come to this. All of this are manifestation of as early as possible. You don't do your demo every day. It is 2 weeks or 1 week, whatever is it. You don't test your code, you do continuous integration every day. It may be once a day, maybe not every, some frequency. Again, there is a sweet spot. Not too early, but not significantly late. So this is the answer I was looking for. All of these practices are there so that we identify problems early rather than late. Now I'll talk about its counterpart. We have principles where we are interested in doing things as late as possible. The practice of finding last responsible moment is we will wait as long as we can before the cost of waiting is counterproductive. When we introduce functionality into software, we wait till we are sure it is actually beneficial. So here the mindset was to do things as early as possible. Here it is as late as possible. Now going back to information or commitment in particular, the principles of information segregation, information hiding, interface segregation and coupling are trying you to commit as little as possible. How many of you are familiar with a single abstract method in Java? Why do we have methods as well as interfaces?
Separate implementations from constructs. Implementations, to keep implementation separate from constructs.
No, that is different.
The implementation differs from
Why do we
scenario.
have both methods and interfaces?
Method is specified. This is what it has to.
Okay. Why do we have method declaration definitions and interface definitions?
To override the functionality on common.
No, interface is more like a
One is granular, one is coarse. Why do we have both?
Information hiding.
No, I'm saying the scenarios where you need to commit at a granular level, somewhere at a coarse level. So that sweet spot varies upon context. So the granularity of commitment can be a method in some context, it can be interface in some other context. That's a takeaway.
No, I didn't get the idea why interface has some different rule.
Interface is a collection of methods. As simple as that. But why do we have both? It's like I'm asking, why do you have integers and why do you have a list of integers? Both have their place. Based upon your context, you figure out the granularity of commitment. Next thing I want to talk about is the waste dimension. Who is familiar with the minimum viable product?
just enough to get it. Basically, you build just enough to get
Yeah.
it to the market. Just bare minimum.
Bare minimum yet functional. If you go beyond that sweet spot, it has so much functionality. If you go outside of side by, it is not useful. So the practice of minimum viable product is to minimize or eliminate waste. Folks, I'll talk about how many are familiar with the concept of evolutionary architecture. The idea here is you automate. How many familiar with the concept of chaos monkey? Okay.
So chaos monkey to ensure my system is very productive, resilient.
So you write code to see how your system will perform under various stresses. Why do we do it? Why do you want to break your code? why do you want to write code to break your own code?
So,
Or even unit test cases. Why do we write test cases to break our own code?
because of we protective are being when real situations are.
Yes.
To make it ready to face.
So why don't developers write better code?
Why
Don't developers write better code?
Developers have certain mindset to follow
No, what's the definition of better code is a important point.
Why do you want to write code which might be buggy and then write test cases for it?
better also has some context, right?
Okay, why don't developers write perfect code?
Perfection is yeah.
Because there are jobs for testing things.
Perfection is
Initial
utopia
slide,
and
initial slide which you said we cannot imagine everything.
Yes. So dealing with information overload, not anticipating everything, these are constraints into our human brain. Hence, we don't trust ourselves. We write test cases to write our own code, see them break our code and then fix them. So, automate as much as possible is the mantra on this slide. We cannot rely on humans to promote something always to production. We don't expect the engineers to test their code manually every time. So, automate as much as possible is the mantra here. Folks, how many of you know infrastructure as code? What is it?
You can maintain your infrastructure as code, so that will help you to look back and provision your infrastructure. Like something is
What was
happening?
happening before this paradigm?
They were doing it manually, doing and creating the infrastructure.
So it was difficult to maintain the state of the state basically. The infrastructure would be able to maintain the state. All the infrastructure was earlier and backward compatible as well, but this was not available in the manual environments when this was not there.
Oh. So when we do the IAS touch code model, what are the changes, what are the new classes that will be introduced?
So earlier it was immutable, and now we made it immutable.
No, let's not go there, but I'm just curious. What new classes were created when you start modeling this?
you separated out various aspects like compute from storage, operating system configurations from.
No, I get that. My question is very simple. What new classes were introduced? As in Java, C++, whatever classes. Is there a class for a machine now? Is there a class for a cluster now?
Yes.
Yes.
Which was hitherto not there.
So you abstracted out those concepts.
No, it's more than abstraction, it's called reification.
And
Reification is a process where something becomes an object or a class in the software world. Unless you have a representation of a machine or a cluster, it's difficult to start, stop, ping, restart a cluster. So, the two takeaways from the slide are, goes back. The more powerful a software becomes, it will have a richer vocabulary. The richer vocabulary is a prerequisite for automation. So, represent as much as possible is a takeaway from this slide. Who's going to look at evolutionary architecture? Did I ask this before? Who's going to chaos memory? Okay. So, why don't people just do it manually? Why do they need to write code again for this?
Again, humans are costly.
Yes. Yes.
So having a code, it gives us the flexibility whenever we want, we can run it.
So, machines don't have emotions, at least not yet.
So you're talking about why do we automate test cases?
automating more. Your test cases, your fitness functions,
The
your
human angle, definitely I understand that is expensive there, but one of the biggest things I think is the repeatability
yes,
that we should have.
yes.
Because you test it today, you identify a bug, how do you know that your fix has not done that regression thing? How do you ensure you, and that's one of the biggest challenges in which actually I'm coming from a different domain, in the broader theory building and scientific practice. There's the whole concept why social sciences is really not computer science because there's not too much repeatability to do. There's a crisis of credibility in even the medical sciences because you just cannot repeat those so many experiments that you get and get similar results. And that has happened. We want to be able to do the same things on a different data set possibly and understand whether if our test cases are different or if we miss out a few then it just goes nowhere. We're finding the same problems again and again and again.
And repeatability is one of the ways of accomplishing is automation. And verification is a prerequisite of automation.
Not necessarily always right. Verification is a prerequisite of automation.
If you can't write, if there's no software representation, what is software work on? When you do unit test cases, there is a base class for unit or a test case. When you automate your deploys, there is a kind of a build.
So from bootstrapping, whatever we have built it, we consider it as part of reimplementation.
No, reification is basically transferring something from your brain into a software representation. There will be a class, object, or what, blah blah blah.
It's an instance of a class.
No,
No.
it is the act of writing code.
And
Your public class method or public class node, something.
I'm differing on your point where you say that we were not able to do a kind of chaos modeling because earlier we were not having the digital representation of these machines, right? But as per object-oriented principle, if we think as a class or object representation in this way,
Yes.
right? The thing is converse, right? Or digitization. It was not there because of virtualization and all that. It was another step. But digital representation, it doesn't mean that I have digital representation. It can really exist.
Look, the software cannot enter the physical world unless it is an interface. Unless you have an object which is of some type called node or a URL or a method, software cannot interact with machines or nodes or clusters. Since the concept of replication is create a software representation of a physical or a real thing. Without reification, you cannot automate. Our end goal is automation. A prerequisite is a step of reification. Somebody will write public class node, public class machine. Unless that happens, you cannot write other code which will consume these classes. That's a takeaway from this slide. Folks, there's all these principles. Assume as little as possible, automate as much as possible, do things as early as possible, do things as late as possible, at as much as possible. So all of this, I have a base principle, which is if it ain't tight, it ain't done.
A quick question I have about these 2 points that you mentioned. Do as early as possible versus as late as possible.
Some things should be done.
Yeah, so I'm just trying to, I would put it as the adding features or adding design or changes to a design be done as late as possible by implementation of a specific design be done as soon as possible. I mean, I would just like to take it this way, that when you are trying to add new features or new functionality, you should be as late as possible so that you are sure what you are doing and the thing that you already have works. And to make that work, you should do things as
the
early.
cost of deferring it further is high.
Yeah.
So I had two graphs in the beginning where I spoke about cost of waiting and cost of a wrong answer.
Yeah, I mean, I'm just trying to point out that these are, they actually are working with sort of different domains.
Yes.
You don't design something as early as possible if it's not needed or featured.
Yes.
But you don't delay implementing it as late as
Look,
possible.
I had a picture in Amitabh Bachchan with so many different principles of women being overloaded. So instead of remembering all of these principles in isolation, I'm saying they're all manipulation of a base principle I'm quoting in this talk. So folks, instead of retrofitting all of this, if this becomes a part of your vocabulary, code should be as compact as possible. They should be as tested as possible, as early as possible. This can prevent ugly conversations in your software development. Yeah, I'll stop. Yeah, any last questions?
What was evolutionary architecture? Align or we don't know basically.
Evolutionary architecture has multiple things. One of them is automate things like license checks, chaos monkey. Make sure you have confidence on your software as it evolves. Not just testing, more than that. Oh, great, sorry. That's a good question. Yes, participation.
This is for people who ask good questions.
Thank you. Folks, I'm out of time. Thank you for your participation. Hope you enjoyed the software.
Can we get these slides? I really love some of the stuff that you have there. Can we get a copy of the slides, the presentation?
Yes. Typically, I put a QR code, but I haven't. I'll share it with.
Yeah, because this is pretty. I came in late, so I missed from all the part, but it's important for us.
A lot of us there on the Medium blocks as well.
Some.
We have implemented one project that we have missed the things which you are telling. Like we were fast and to start the project. We have to kickstart the project, we have to develop the things. And when this comes down, we are very slow and we are releasing the project. It's very valuable. So this was actually happened. This was actually because like we are aiming, like when we are developing that minimum viable product. When customer wants a car, we are actually making a tires and the other things we are developing. But that's not the way. We have to make a cycle at least. Then the customer moves on. So that way we should have been done. But we made a mistake there. Like we were building a parts of the project rather than the usability of the project. So valuable things. It's a takeaway for me. Thank you. Thank you, Naveen, for your time and sharing your knowledge.